Theoretically. We'll see if it gets there.
Looks like it says webinar is now streaming live on YouTube.
It's trying. Oh, there it went. There. Yeah. Hello,
I don't
Twitter.
see.
Hello, YouTube.
How would I check LinkedIn streaming?
We have events under the highlight account. So go to events and then click into it. Oh. We need to how do we promote to panelist. Griffing's screen share is now promoted to panelist.
Awesome. Thank you. Is my video choppy for you guys? Just want to make sure the recording isn't messing that up.
No, looks
Okay.
good.
Cool.
Fine.
Just double checking.
Is there a way to like post about it?
I don't
Yeah.
know.
On LinkedIn?
I did. I posted on X, so that's taken care of. YouTube pretty much handles that on its own.
Jay, I'll message you.
All right, and make sure we spotlight my screen share real quick.
Yep.
Yeah, I see it. It's not letting me save. Oh, I need Pacific time. This is very weird.
Let me make sure that. Let me make sure the Loom is updated.
Interesting. The
The
LinkedIn
link-
one, I think he needs to be started on LinkedIn or something, or it's not starting.
Yeah, it says pre-live, not live. Yeah, if I click to join, maybe that's when you can control that. But if I click to join, it says this event will start soon. Wait for the host to start.
Oh, in LinkedIn.
Yes.
And I also don't see it on YouTube.
There, I'm going live.
Okay. Yep.
Great.
There we go.
Looks good on LinkedIn.
Okay,
Can we check?
Should we play some fun background music? Is someone sharing audio?
There, I'm going live.
Okay, people are coming in. People are coming in.
Looks good on LinkedIn.
Great. Okay, should we play some fun background music? Someone sharing audio? Okay, Esplin, we can hear your audio through here.
We're just giving folks a few more minutes to join as we figure out some of this logistics of streaming. So bear with us. We'll get started in a few minutes.
And yeah, Vadim, on the YouTube end, is there anything, or you're not seeing it? Is that what you're saying? I'm clicking in right now. I don't see anything live, Esplin, on YouTube.
I could do some a cappella music while we're loading in. You know.
Yes,
Boop,
please
boop,
do,
boop,
actually.
boop, 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 boop.
Maybe
Sorry,
we
that's
just
all I got.
maybe we just shouldn't talk about OpenTelemetry and you just do that instead.
Right, there we go. For April Fools, that would be a really good one.
Esplin, I think the last thing we're waiting on is to make sure that YouTube is live.
Do you
It
hear
is.
us? That's oh.
Yeah. YouTube
It
is live.
doesn't seem like it's live if we visit the YouTube stream.
Oh, I see it.
Is it public?
It's working. Oh, it's unlisted. Why is it unlisted?
They
Okay.
default to that. It's super annoying.
Why does it do that?
I think it does it based on your most recent publish. So if you have something that you're waiting to like push out.
I hate that so much.
Yeah, I hate it too.
That is the worst. Okay, it's definitely there.
I'll see that. It's super annoying.
I'm going to mute you, Esplin. And just an update for some of the other folks that have joined since we started. We're just giving it 3 more minutes and we'll get started shortly. Bear with us while we figure out some of the logistics here for streaming.
And then I don't think I see anything on Twitter either. Oh, I do see it on Twitter, actually. Great.
Last bit is YouTube. It still is unlisted. Oh, I see it now. Okay. I see it now. Awesome. So yeah, we can just start it at the 10-minute mark, Chris.
Sure. Sounds good.
One more thing is think the I think the event on Luma hasn't officially been started. And that might be why people are not getting notified of it. So I'm gonna go ahead and do that.
We at least have someone using the question and answer, which is nice. While we wait, they got to ask, if we were a vegetable, what vegetable would we be and why?
I think I'd be a taro root. I want to bring savory sweetness into people's lives.
Okay. It's a good one. I mean, I can always just do the Shrek reference, an onion, right? Because I've got layers.
It's a good one.
I think a pepper X counts as a vegetable, doesn't it? Can I be a pepper X?
Spicy.
Wouldn't you
That'd
like
be
to be a
spicy.
pepper too? Sorry, I'm
Okay,
basically
Chris.
walking movie references. So yeah,
Oh.
Are we ready to go?
I think we're good to go.
All right. I believe Esplin, go ahead and take us away with the intro and where we're going, and I'll get the slides going for you.
Okay. So first, introductions. My name is Chris Esplin. I am a JavaScript engineer, and I work mostly in the SDKs, and I also do a lot of sort of developer advocate, DevRel, marketing, whatever you want to call it, produce podcasts, stuff like that. Let's pass it off to Chris Griffin, one of the two Chris's on this stream.
Yep, just another Chris. So I'm Chris Griffin. I'm a developer advocate at GitKraken, and I'm just really stoked to be guest starring here on this workshop to talk about OpenTelemetry and how to integrate with Next.js. I also stream a lot on Twitch, like 5 days a week, and I am pretty lazy about making YouTube videos, but I'm trying to be better about that. On to you, Jay.
Cool. And yeah, I won't be as involved in this stream today, but good to see everyone here and excited to learn more about the stream. My name's Jay and I'm the CEO at Highlight. I run the product and sales teams here. So yeah, excited to learn honestly on my own accord about OTel and Next.js.
And my name is Vadim. Nice to meet everyone. I'm the CTO at Highlight, and I run the engineering team here. Really excited to share some more about OpenTelemetry. I know it's kind of a mysterious topic for folks, so over to you, Chris, to kick us off.
All right, so yeah, I'm gonna get to the agenda, and I just want to point out I wore my fancy hoodie today because this is a special event. So we're going to really get into what OpenTelemetry is, how it's useful, some basics about it, some terminology. I want to walk through setting up the collector yourself and some things around that. And then finally, how to integrate with Next.js itself using, the SDKs from OpenTelemetry and how Highlight can make some of this stuff easier. So let's get going. So first off, why telemetry, right? Just telemetry in general. Well, most APIs and backend services are a black box. We only see the inputs and the outputs, the request and the response. So if we want to measure the timing of something, we just see the entire thing. Whereas telemetry allows us to see inside of that and see which parts of our application might be slower or faster, or which types might be causing errors or just could be better. Now, next up, why OpenTelemetry? Well, a lot of telemetry vendors before OpenTelemetry existed were very, very specific. They had their own way of doing things, and changing from one vendor to another was actually a huge ordeal. And you ended up being locked into a specific vendor because changing vendors, would be more costly than just paying the bill month after month. So now with OpenTelemetry, it's vendor agnostic, and you should theoretically be able to change vendors much easier using the same SDKs and the same specifications and such that, it just makes a lot of our lives easier as developers to really pick a vendor that fits our needs. And the cool part about OpenTelemetry is that it is a CNCF incubator project, very much like Kubernetes or things like that. So that it's at least got a lot of big companies behind it, and it's not going anywhere. So that's one of the big things to worry about when we think about some of these, just another standard for everyone to use. Now we have 17 standards, right? This is at least a standard that we have a lot of backing behind from the CNCF and big companies behind them. And just like Kubernetes, it's not going anywhere. So when we talk about OpenTelemetry, there's going to be some core concepts and then some other terminology we want to learn. The main core concepts are really just the parts that make up what OpenTelemetry is, the specifications of it. So the first step is traces. Traces are the big picture of a request to your API. So let's just think the entire request itself. It's the big picture, and it's made up of spans that make up the smaller parts that we can actually measure individually. Things that we can, attribute and graph and see really good CPU results, et cetera, things like that. And that's where metrics kind of come in. So metrics are a measurement of availability or performance. It could be your CPU, your RAM, or even latency of making fetch requests to a third party or things like that, or to your database, all sorts of stuff like that. Next up, we have logs. And I think most of us probably know what logs are, but in the OpenTelemetry context, it's a very specific schema that is just a time-stamped text record with metadata that we can then search through. You've probably seen that in pretty much every vendor for telemetry in general, right? Just being able to search through your logs, see how a user might have gotten to an error, and finally debug it because you can't be there on their machine with them. And last but not least, that we're not going to get too deep into baggage, but baggage is more like some contextual information that you pass along from span to span within a trace. And this allows you to kind of tie things together and understand a broader scope of the user's path through your application. You can tie traces together using baggage so that you can actually see what a session might look like. like a user's path through the whole application, not just one request response cycle. So some more terminology, right? OpenTelemetry basics. There's OTLP, which is the OpenTelemetry protocol. And there's a couple ways of dealing with this and thinking about it. There's the gRPC aspect of it, which is really like the way that the data gets sent. But there's also the schema of it, which is protobuf. And you can send that over HTTP as well. But OTLP is a very specific way of just sending all this data in a very stable way. And the protobuf itself actually has like fields that they label as stable versus like experimental or new. And the stable ones, you can rest assured that they're not going to go away. So they're not going to break things, because that is very important when you're dealing with protobuf in general. Another thing to really be considering is the collector. And we're going to get way deeper into what the collector is and how to set it up. But I at least wanted to give you a description of it. And it's basically its own service that takes in the OpenTelemetry schema messages and processes them in some way, possibly scrubbing for personal information, right? PII, possibly, adding extra context and metadata. And then finally, there's the exporters, which really sends it out to the databases where you might want to store some of this telemetry, such as Jaeger for traces, or Zipkin for logs, or Prometheus for metrics. There's just all sorts of stuff that, you have these very specific databases for storing different types of telemetry, because querying them is different with each one. And you want to optimize for that performance in a certain way, or the way it gets stored, or things like that. So having these different databases is actually really important. And then the next thing is instrumentation. So instrumentation is how we measure these things in our applications. There's things like automatic instrumentation, where you might just wire up something that hooks into Node's HTTP libraries. So if you're not using fetch, there would be the HTTP library that, HTTP or HTTPS, where you're maybe making a request to a third party, and you want to make sure that that is measured so you can determine if a third party vendor is maybe slowing you down when they shouldn't, especially when you have maybe an SLA in place. There's also custom instrumentation. This is typically what you would write in your application to measure the parts of what you are doing specifically, not what third parties are doing, not what system libraries are doing, but what your application is doing specifically, such as maybe parsing a CSV file or things like that. You may want to just measure certain parts of your app to make sure that they're not slowing down your user's experience, because that's important. And then finally, there are libraries that you might want to have instrumentation for. Typically, it's on the libraries to implement these things, but we don't have access to that. So they need to expose out the spans that we care about and things like that. So there's 3 different major types of instrumentation. We're mainly going to be talking about the automatic and custom today, but libraries also need to ship their own instrumentation for what they do. So first off, let's make sure we talk about what we won't cover today. The collector, like I mentioned, is a service. You might be running it through the Docker container. You might do it a different way. If you're not using Docker, you might just pull down the file for it, which is quite large. And who wants to actually waste time scaling the collector? I definitely don't. That's why third parties like Highlight, like Datadog, like any of these other companies are useful, because they can handle that scaling for you. Anytime you're wasting effort scaling some service like that, you're taking away from time where you're actually working on your service, not just a thing that's trying to aggregate this stuff. Another thing we won't cover is client setup. So client telemetry, etc. That is very, very experimental right now. And a lot of vendors are kind of figuring out their own way to do that. And I think at some point they will all kind of converge on something that OpenTelemetry can adopt, but it's still experimental and not going to be covered here today. And that also kind of ties to what user sessions might be, where you might have client-side telemetry tying back to your server-side telemetry, and kind of gluing that together to get a bigger view of your user's path through the application. That is, we're going to touch on it on how Highlight does it, but that is not something that OpenTelemetry really covers at all. And then last but not least, logging, which should be standard, but it is still under development for the Node.js SDK. So we're not going to dig too deep into logging, but I do want to point out that it is worthwhile and useful, and it will be a thing that is available in the Node.js SDK for OpenTelemetry at some point. So yeah, we're going to dig into setting up our own collector. Keep in mind that it's actually not 100% necessary. You could just send data directly from your Next.js application, from your APIs, from whatever, directly to the database where you're going to be storing these things like Prometheus, like Jaeger, like Tempo, like Loki, etc. You could totally just send that from your app. But once you start adding other services, other microservices, other things that you want to send data to the providers for, you're actually going to have to duplicate a lot of that effort. And that's what the collector can help you with. So we're going to dig into even some more things that the collector can help you with, such as processing and scrubbing data. You don't want to recreate that in every service that's sending this data out to third parties like Grafana or whatever. So yeah, not necessary, but highly recommended. Now, this is something that I discovered in my own dev, just because I have a repo where I built out some demo stuff, and we're going to be seeing some of that code. But the collector is a 264 megabyte Go binary. So if you are building out a proof of concept that you just want to be able to like host and share with the rest of your company, you probably want to have a script to download this instead of just pushing up a 264 meg binary to Git. So you probably want to Git ignore it for at least proof of concepts or demos. And yeah, so when it comes to configuring the collector, there's really like the 5 important parts, and really it kind of boils down to like 3 and then a higher level bit. But let's kind of like walk through it now, and then we'll kind of talk more about it as I show you some code. So a receiver basically takes in data from your application. And that could be via OTLP and HTTP. It could be some syslog TCP stuff. It could be some other stuff I don't even know about. But the idea is that the collector is agnostic enough to take in all sorts of data from basically anywhere you need it to, which is why it's so useful, because then you don't have to worry about how does this actually get shipped out to Tempo or Loki or Grafana or whatever. So the receiver takes in data from your services and then passes it on to the rest of the pipeline, which is going to be the processors and exporters. So then when we talk about processors, those are the things that might batch your requests together for sending out to your vendors. It might be scrubbing for personal data. There's all sorts of ways that you might want to add extra metadata to things, and the processor is the place that happens. Extensions aren't necessary, but they are useful, and they're a way of basically defining something in one place in your collector config and then reusing that in other places. So it might be some reusable user ID data or authentication data or things like that. And an extension is just a way of sharing something instead of copying and pasting it between all of the other processors or exporters or whatever. And it's more generic than just exporters and passwords and stuff, but that's the use case that I used. When we talk about exporters, that is what's actually then going to send things out to something like, Jaeger or Prometheus or Tempo or like Grafana Cloud or any of that stuff. That's where you're going to be defining the endpoint that you want to hit and maybe some of the authentication stuff that you care about, because it might not be shareable between them because they might be unique to each exporter, things like that. And then finally, the idea of a pipeline is just gluing together the receiver, the processor, the extensions, and the exporters. So it's really just like the higher level thing that is using these composable pieces together. And we're going to see how that might be useful here in a second. And then finally, connectors, I'm not going to be covering much because I'm not really that familiar with them, but my basic understanding is that you can combine either multiple pipelines or multiple like processors and exporters in a more shareable way among things to reduce a bit of your like duplication and boilerplate. But I'm less familiar with that, so I may have misspoken about it. One thing is, if you don't want to go through the process of setting up your collector, right? If you just want to get up and running to try out OpenTelemetry with Next.js, Vercel has a really good dev environment. That's just a Docker instance or a Docker container that has a pre-configured collector that has local instances of Jaeger, Zipkin, and Prometheus. So Jaeger for traces, Zipkin for logs, Prometheus for metrics. And it's just a nice, clean, easily packaged way of just Docker compose up. And then you have this thing that you can actually hit from your application just to see how this stuff works, just to see what your data might look like. And maybe even like query it and pass it to somewhere to visualize things. So now, demo time. Let's hop over to my code. So first off, let's go to my collector code here. And this is going to be config.yaml. And in this collector code, let's go to the top. This is the config.yaml file for collector. And basically, I've defined the receivers. Right now, we're just doing OTLP, but we do have two separate protocols we want to support. So we can support the gRPC on one port and the HTTP on another port. And it's just nice and easy and really quick and easy to configure. So you don't have to do this part yourself. From there, right, it's going to take in data from the receiver, and then it's going to pass it to the processors. And processors might be something like batching, batching your OpenTelemetry messages into one single message to maybe keep from getting rate limited by, a third-party vendor. You might want to limit the amount of memory that, some of these things are going to deal with. So like the memory limiter might be specific to a certain pipeline. That way, that you're not taking up all of the RAM on this machine, so you have some headroom for spikes. And there's all sorts of other like processors where, again, you might want to scrub personal data. I didn't deal with that much, but it is a good use case. There, basically anything you would want to do to transform the OpenTelemetry before it gets sent out to an exporter. And then from there, we see this extension, which I'm not actually using anymore. I did mess with it and fiddle with it. We can see I even did some HTTP password stuff. But this was just me trying to understand what the extensions were good for and how I might share out this data and use it, like the username and password in possibly multiple exporters, etc. So from here, when we look at exporters, there's actually one really useful exporter, and this is the debug exporter. And all it's going to do is print to the terminal from your collector. So if you're just spinning this up locally to test things, this might be the first exporter you really deal with. And it's just going to be, printing to your terminal, and you can have it verbosity detailed. There might be some like simpler stuff to like prevent like all of the, just the flood of data from the logging. But it's extremely useful just to like understand what's happening before you start dealing with setting up vendors and, Grafana, cloud, or whatever, right? From there, we see that this OTLP one is like a generic exporter that we then configured for Tempo in Grafana Cloud. One interesting thing is if you want to have multiple of these like generic OTLP providers, you could just do OTLP Tempo, and then that would then allow you to have another OTLP / something that is defined that way. So that was really interesting when I was doing a bit of, just experimentation and trying to figure out how to reuse some of this stuff. And yeah, basically what we see is we're setting the endpoint for it. We're setting our auth, which is different from the auth for these others, right? Like if I'm doing username password for basic auth Prometheus, I might have a different way of doing auth for, Tempo or Loki or whatever. So now we see Loki, same idea. This is where the logs are going to be going. I just define a different endpoint we're going to hit. I define the authentication stuff. And there's also going to be like individual config you might do for each individual exporter that they kind of define for each one. And last but not least, Prometheus Remote Write, which is important to recognize that Prometheus Remote Write is different from the Prometheus exporter. So that was something that tripped me up when I was learning about this stuff. The Prometheus Remote Write is the one where if you're using a third party like Grafana Cloud, that is the one that you want to use to actually push data to. And then last but not least, there's the file exporter where, yeah, just maybe you want to have this as a backup on your machine or something. You're still going to want to have like a middleman DB in general for a lot of this stuff because you need to be able to pull from those databases like Prometheus, like Loki, like Tempo for visualization in something like Grafana. So being able to actually like access this data in a way that you can see things is probably more important than just having a file where you dump it all. Right? If you never look at the data, it's not actually worthwhile to have. So now that we get to this service section of the YAML, this is where the pipelines happen. This is where we're gluing together all of those things we just defined. We can see the traces are going to go and get a receiver for OTLP. And it's possible that we might have had another receiver, right? We mentioned syslog, TCP stuff. That could totally be in here too, right? We can define any of this as we see fit. I'm going to have the memory limiter processor going on this. You'll notice that I commented out the batch processor. That's because I'm on the free version of Grafana Cloud for the demo that I did. And when I was batching things together, I was actually getting rate limited based on the size of my request. So I actually needed to just send individual messages to them. But you will most likely be on not a free tier, and you'll want to actually batch things together just for, preventing rate limiting. But we can see that here in exporters, we could define debug and OTLP, right, which would be our tempo exporter. And maybe we don't want debug. We can actually decide which of these traces get logged out to the terminal and don't, which ones go out to a third-party vendor or not, things like that. We do the same thing for metrics. Most of these I'm going to be duplicating a bit of what I'm doing, but your larger applications may totally want to do things differently based upon which pipeline you're trying to target. So I hope that made some sense. I think we're going to go and visualize what this kind of looks like. So here's your app, right? You might be sending data from your app or your microservices or your API, all sorts of places via different methods. And those get sent to the receivers and kind of like through this pipeline of receiver to processor to exporter. And then from there, the OTel collector sends that stuff out to the services that you're using, such as Grafana Cloud, etc. So now that we've kind of gotten over the collector and what it's useful for, why you might want to use it, how to configure it, we need to actually get into the part for why you're here, configuring Next.js integration. And there's really just two main ways of doing that. There's the @Vercel OTel package, which is really, really awesome, really useful, and it works everywhere. It works on Edge. It works in their Node.js environment. It'll work if you're self-hosting as well still, which is really cool. When you're doing a manual integration, the Edge is actually not supported. There might be some ways that you can hack around that using some APIs, and we'll get into some of that later, but we can just basically assume that manual integration does not support the Edge without a whole lot of extra effort. And for both of these types of integration, you're going to end up needing to add this experimental instrumentation hook. And I think that's important because Next.js doesn't want to slow down people's instances if you're not using OpenTelemetry, so it's an opt-in. And I think that's a really important thing anyway, right? Just if you don't need it, why have it? So you do need to have this in your Next config in the experimental section, and you just set instrumentation hook to true, and that is going to tell Next.js to look for this instrumentation.ts file. So before we get into the actual integration parts itself, I want to talk about the default spans that Next.js does for you automatically. And that's most likely being turned on by the instrumentation hook as well, because again, you don't want your request slowed down by pushing out to, the tracer if you're not actually using the tracer. So yeah, this is probably going to turn on, the instrumentation hook is probably going to turn on these spans. And this is some common metadata for those spans. So, right, span name, kind of straightforward, makes sense. Span type is going to be unique for each span type you might have. There's the next route that's being hit. So that would be, the exact full path. Whether RSC is on, so that's a true false, just telling you whether it's an RSC request for a prefetch or things like that. And then there's going to be the next stop page, which is really about your higher level meta pages, right? Or meta routes, such as the page.ts file, the layout.ts file, or the loading.ts file, and other stuff. This is not unique to a specific request until you attach something like the route. So, right, you'll see next.page and layout.ts all over the place. You don't know which that is until it is combined with a route for that layout.ts. But we still want to be able to maybe track which part of your application is fast or slow, right? Your route that you've defined might be really fast, but the layout around it might be really slow. So now let's actually talk about the spans themselves, right? Because that metadata helps us search through things, but we need to know what spans we can actually aggregate on and, to understand our applications better. So there might be the method and the route for the request to your Next.js app. There might be a fetch request to a third party, which is something that Next is instrumenting on their own and, pretty cool. There's generate metadata, which is for just, the process of generating metadata. If that's taking a long time, that's a problem, right? And you still want to know about that. Resolving page components is important. Resolving segment modules for maybe imports that you're doing inside of your layouts or pages. And then the start of the response is actually really useful because this is a zero width span, right? So it's like a span of just a moment, but it is it marks like the timestamp of when the first byte of the response was sent. So that's incredibly useful to just understand when your response has actually started sending something, because there is the concept of streaming with Next.js. So you want to make sure that your application is able to like understand whether you're streaming a lot of data and that was slow, or like whether you were slow before you even tried to send the response. Then there's going to be some extra spans that are specific to the type of router you're using. So if you're using the app router, there's going to be render route, next.route. There's going to be executing API route. And these are just really useful. If you're using the pages router, there's some separate things that just won't make sense in the context of the app router, such as get server-side props, such as get static props, and render route just pages to like know what's separate and, because it's going to be a different measurement than it would be with the app router. Now, if you wanted to do custom spans, this is where it gets pretty interesting. Let's say you're doing some CSV parsing, like manual CSV parsing, and you want to transform it into something that you can then send up to the client. You might want to measure that CSV parsing part. Here in this example, copied from OpenTelemetry or the Next.js docs, I think, we see that this is just about fetching GitHub stars. That's pretty basic. You're probably going to be able to instrument that just using the fetch span that Next.js does. But what if you had some more work you were doing, such as parsing CSV, such as just other things? You would probably want to measure that part specifically and create a span related to your trace that you could actually understand later and determine if it's performing slowly or not. One important aspect, though, is if you're doing an async kind of like active span here, and the thing you're fetching is async, you want to make sure you're doing a finally, because if you don't end that span, it's going to really mess with how you're measuring things. So you got to make sure that you end this span at the appropriate time. Otherwise, it'll mess up a whole bunch of your data. So now we move on to the Vercel OTel package. This is the first way of doing a Next.js integration, and it really does just solve a lot for you with basically one line. I mean, it's multiple lines, but the line that's important is that register OTel. I do want to mention what this register function is, though. This runs once for the entire instantiation of Next.js, and it'll stay active. So if you want to set up a bunch of like globals or things that are supposed to be persistent through the rest of like a rendering of your application, this might be a really good place to do that. It's not just for instrumentation. It could be for setting up globals or other things. But here we see the simplest way of doing register OTel with the Vercel OTel package, and you just pass the name of your app, right? So next app, and we're done. But if you want to do a lot more, right, and configure and decide what's going on with the Vercel OTel package, they have a bunch of stuff you can do here. And I feel like a lot of this is actually getting proxied to the Node.js SDK under the hood, or possibly the Web.js SDK, I think, from chatting with Vadim. But the idea is that, yeah, like later when we're looking at the manual integration, you're going to see things like span processors. You're going to see things like instrumentations. I'm thinking ID generator might be unique to the Vercel OTel package, but I'm not necessarily sure because I haven't dug into all of this stuff. If you want to get into this, check the Vercel OTel documentation. It's really good. And yeah, I think that would be the best way to learn more about the really custom configuration you can do with that package. But instead, let's go look at the manual integration, because that's the fun part, right? So when we go look at the manual integration, we get down to it. Here we see the instrumentation.ts file. I'm logging out what runtime we're in, because remember, I mentioned that manual integration isn't going to work at the edge out of the box. So instead, you're going to want to make sure that you're only including this instrumentation.node.ts file when you're in a Node.js environment. And this applies to self-hosting or Vercel in general. So make sure that you're, blocking that out and making sure that it's only accessible in the Node runtime. So now that we've seen that you have to do that, what we can do is check out the instrumentation.node.ts file. And this one is way more interesting. Right? We see a lot of imports that we're getting at already. I'm not necessarily using these because I commented out the code that does that part, but we're going to dig in and look at it. And this is the cool part that I think is just really nifty for the Node.js ecosystem. So we see this library, auto instrumentations node. And this is going to allow us to hook into all sorts of stuff. So we're going to create the node auto instrumentations. We're going to maybe add some hooks and config for them. And one of them might be if you're using Pinot for logging, which is a really useful log tool, you might still want to hook into that log hook and then add some extra data to a span for it, right? You might want to like instrument the Pinot logging and get that sent out to your collector without having to do any like custom logging. So if you log with Pinot, it can then automatically proxy as a log to your collector. Keep in mind, though, that this doesn't currently work the way I expected it to, and it may have been user error. But because I think the Node.js SDK's logging is still under development, this wasn't as useful as I think it could have been. But I still think it was worth showing off that there's all sorts of stuff that this instrumentation Pinot library, or that this auto instrumentations node library can instrument, such as Pinot. It can instrument HTTP instead of fetch like Next.js does. So if you end up doing Node.js stuff using Node HTTP or Node HTTPS, you can still instrument that automatically without any extra effort, right? And then maybe apply some custom attributes to a span. I also wanted to disable instrumentation FS because I didn't find that useful when I was trying to learn about this process. So when I was looking at my Grafana, it was a bunch of noise about the file system stuff, but that could still be something you want. But there's configuration for a whole bunch of these like things that get auto-instrumented, such as the file system, such as HTTP, and you can decide which things you want or don't. And then from there, we need to make sure we register those instrumentations. That is coming from OpenTelemetry instrumentation, not necessarily the auto instrumentation part of things. And it's not coming from the SDK either. So it's just another way of like, it has to register these to make sure that they're actually firing in the way that matters because it's Node.js specific. And then we still also need to make sure that we pass that to the instrumentations here in the Node.js SDK as well. Now, what you might see in this SDK is, right, this next app, that's what we were passing is just a single string to the Vercel OTel package, right? We can see trace exporter, span processor, log record processor. Those were also just config options in the Vercel OTel package. But there may just be some extra stuff that you want to add to the Node SDK that they might not support yet. I'm not sure what that is. I'm just saying there's a possibility, and the Node SDK might be a way for you to get that happening. And then finally, a really important part, make sure you start the SDK. If you don't start the SDK, none of this stuff's going to happen. Know how I know? I made that mistake. So, right, make sure you do this. So yeah, we're kind of like getting towards the end of it here. One important thing is there is a way to do manual integrate or like to do edge support with a manual integration, right? So yeah, OpenTelemetry/Node is not compatible with the edge runtime, but OpenTelemetry/WebJS is. And the important thing to recognize is that Vercel edge functions run on Cloudflare workers, which means that this wait until API is available. And the Cloudflare workers thing is at least something I found from a comment by Lee Robinson. It could have changed in the 2 years that comment was made, but I think this is still true. And at this point, I'm going to hand over to Vadim to Chris Esplin to tell us a little bit about the wait until API and how he dealt with it in the SDK.
Excellent. Do we need to remove your spotlight, or is this going to work? There we go. All right. Yeah, I don't have a whole lot on this, but it's more of just a warning. So this can be done. The trick is we'll wait until the Cloudflare worker has completed its work, and it'll let you keep that Cloudflare worker alive. And that's critical because the way that OpenTelemetry works, it's flushing all the time. It's flushing your messages out. So what you need to do is you need to be able to keep your worker alive until all the messages can flush. I ran into all kinds of difficulty with this when I was setting up highlights edge support. So if you're going to do it manually, that's a really important little detail to keep track of. Otherwise, I suggest going with either highlights SDKs or the Vercel OTel SDKs.
Awesome. Thanks. So yeah, we kind of talked about OpenTelemetry. We talked about the basics and how you can build it yourself and do a whole bunch of work on your part. But how does Highlight actually help? Well, number one, Highlight can give you logging. Highlight can give you error tracing. Those are things that we didn't cover today, and I am less familiar with them, especially because the Node.js SDK doesn't support logging yet. And then there's also the coolest part, I think, is session replay. And I'm going to let Vadim take over and talk about how Highlight kind of solves some of these problems and how you can use it to get that functionality.
Thanks, Chris, and thanks for giving such a deep dive on OpenTelemetry. And you kind of hit the nail on the head saying that OpenTelemetry allows us to send data to a bunch of different sources. But if you're the end user of this, you still have to manage the infrastructure for running Loki or Tempo or any other sort of analytics database to ingest all that data. So the nice thing about Highlight is we'll manage all of that for you as one cohesive stack that brings that information together in a way that's useful for you to debug performance regressions, errors, or other problems with your application. So I'll just walk you real quick through that Highlight UI. Just make sure I'm sharing my screen here. Cool. And so this is just a look at traces in Highlight. So you get like a classic sort of viewer of all of the spans. What's up?
I'm not sure they're seeing your screen yet. I think
Okay.
my screen still seems like it's showing. Let me stop my share and then you can take over.
Oh, yeah.
There we go.
Okay. Awesome. Thanks, Chris. Yeah, so you have like a classic viewer of all of the spans that you're ingesting. So for example, you might be sending over those Next.js spans from the back end. You're going to be able to look at each one of those, sort and search them based on structured attributes, look at things like the slowest ones, find ones that are interesting to you. And then for each one of these, you can pull up a full flame graph that'll show you how this relates to all the other spans within this context. So like there might be some slowness in a particular part of your code base that you're interested in, like a SQL query that you're trying to debug. You'll get all of that attributes in one place to look at. But the nice thing, as Chris was saying, is we have session replay and logging and error monitoring. So we give you a full picture at the rest of your stack too, so that you can see like what impact did a particular code execution on the server, a particular exception actually have on the end user. So if we switch over to the error product, we can look at all of the errors that are being ingested from our stack. And for this particular Jira issue, we might have a stack trace, but we don't actually know if this is breaking anything for this person. We'll get to see the exact user on Highlight that experienced this error. And just with a click of a button, we can play back what Chris in this case was doing at this particular moment when he experienced this issue. So really, it's just Highlight gives you a place to send all of this OpenTelemetry data, collect it alongside all of the other stuff that is relevant for debugging an issue, associating it with the front end browser impact that an error has, and giving all of that in one cohesive view. So with that, I will continue sharing my screen actually, and switch back to our closing. So
Awesome.
back
So
to you,
yeah,
Chris.
thank you, Vadim. Appreciate that. That was great. So, yep, I really appreciate Highlight for giving me the chance to actually like learn about OpenTelemetry and dig into this and present my learning to you guys. I'm definitely not the expert about it, but if you want to learn more, check out the Next.js OTel docs. They were really good. I was basically just regurgitating a lot of the things I learned from that and the OpenTelemetry official documentation as well. So I basically just glued all that together for you. I recommend reading that stuff to get like a more high level like understanding of things. And I guess at this point, are there any major questions? I do see one below. If you can, kindly do a brief on how you get metrics such as error rates, throughput, and latency. And Vadim, I'll let you take this.
Sure. Yeah, so all of the information that we're ingesting in Highlight, so across the sessions, across individual OpenTelemetry exceptions, the traces, the logs, all of that's coming in and is graphable both in Highlight and in other visualization layers that can use the data that we're collecting. So for example, error rates, right? You're just trying to look at how many times errors are happening in your application over time. So you can build a chart in Highlight that will show you exactly that. And I can actually put up a quick demo here. Let me just give me a second here. But yeah, you can look at exactly that information to visualize over that and also alert on it. So for example, if your number of errors over time spikes, past a certain amount of past a certain limit, you can set up an alert to get notified so that your team gets notified about that particular problem happening. So I have here a quick
sorry,
graph.
real quick. We only see the slide right now. There you go. Cool.
Yeah. So we have a quick graph here of how many times errors are happening in a different session. I can graph this over a larger time window. I can customize how this graph is actually set up so that I can graph the number of errors, not by session, but maybe by service name or some other interesting attribute where I can now understand, oh, is this a new error that I just introduced? Or is this something that's been around, filter out noise, etc. So this graphing and metrics view and highlight is really powerful in that it gives you the ability to customize this a lot and graph at this in all sorts of ways that you want. Plus, we have the ability to integrate with Grafana, as I mentioned. So if you're already using Grafana as the visualization layer for other kinds of metrics, you can do that. And I think you mentioned a few other metrics in that question, maybe like throughput, API latency, that sort of stuff. This is really configurable and allows you to search for all that information across all of the data that Highlight is collecting from OpenTelemetry. Just to touch on one other quick point in terms of logging, I know that's something we didn't have time to discuss in detail in this chat, but the way that we support OpenTelemetry logs is via the experimental log spec, but also via trace events. So one thing that traces in OpenTelemetry already have is an arbitrary number of events, and you can send exceptions as events, or you can send logs as events. So that's how we ingest those and still store them and display them for you. So it's really OpenTelemetry compatible, and we try to stick with the OpenTelemetry conventions as much as possible.
Okay. And I think more to the question as well, how would we do this in like a manual way? Well, that's what the auto instrumentations and like the Next.js instrumentation are kind of doing for us. When there's an error, they're sending that to the collector for us, right? So that like wiring is kind of happening under the hood automatically, whether we do the Vercel OTel, that would be automatic for us, or whether we do the manual, that's what like the auto instrumentations are kind of going to do as well. So like the Node.js auto instrumentation is most likely sending those exceptions along for us. Cool. So I think that kind of sums it up. I'll let you guys do the outro.
Sounds good. Any other questions just real quick? We have a few more minutes, so I don't think we have any, but maybe we'll give it 30 seconds or so. But yeah, with that, Chris, thank you so much for the deep dive. I think our audience has learned a lot, and yeah, it really shows how much work goes into setting up OpenTelemetry, how much it goes into setting up OpenTelemetry for different kinds of stacks. And yeah, you did an amazing deep dive over all of that. So thanks so much.
Thanks. We do have one more quick question. Any comment on metrics readers? I don't know what that means, so I'm going to defer.
Yeah, if you're talking about OpenTelemetry metrics specifically, that's a particular spec that we're working on supporting. We don't support right now. The difference there between sending metrics as like trace events versus using the native OpenTelemetry metrics spec is that the metrics spec builds in aggregation at the SDK and collector level. So for example, you might have like a very high throughput code base or like a particular function that can be called really frequently and is latency sensitive, right? So you don't want to be sending each one of those invocations out to Highlight or any other provider that's ingesting OpenTelemetry. What OpenTelemetry metrics allows you to do is to use the individual events that you're sending and aggregate them at the application level so that you get a larger bucket, but with an average of that metric over time. So let's say, for example, you have a number of messages as a metric that you want to emit. And you might be sending that metric for every single invocation of your function. Every second or every millisecond, OpenTelemetry's SDK will roll that up into one value that's an average over the many different invocations that happened within that second. And then that value will get sent to the collector where it can be rolled up across different services to an even higher aggregate. And so the metrics spec is really efficient. We're working on supporting it, and we'll be visualizing it in the UI pretty shortly. But right now, you can extract metrics out of traces. So if you send a metric event via a trace, you'll already be able to visualize that in Highlight.
Awesome. Yeah, thank you. So really appreciate everyone showing up and enjoying this webinar with us. And thank you for letting me present to you. And I hope you all have a great rest of your day.